A warm good afternoon to all. Today we are going to see a most important topic which is known as precipitation strengthening. It is predominantly used in non-ferrous alloys. Okay, what is precipitation actually?
Precipitation strengthening is a type of heat treatment process. Precipitation is a small solid substance which is occurred in a supersaturated solution when it meets a certain temperature. That's small solid particles that are segregated, those are known as precipitation. And strengthening, it's like increasing the properties of the metal to withstand some amount of loads or something. This is known as strengthening. The precipitation strengthening is also known as edge hardening or aging. It is used to improve the physical properties of the material. It's almost used in the magnesium, nickel and aluminum. In this process, in this hardening process, it takes the phase from between the fine particles to phase are formed.
So, as our friends say, this is we are going to study this precipitation hardening technique. We'll be taking aluminum 4% copper alloy as a consideration. So, this aluminum 4% copper is nothing known as duralumin. So, here are the steps for it. First one is solution treatment, quenching and aging.
So the process which will be covered from the aluminum and 4% of copper alloy, which is known as duraluminum. From that, as I said, the steps will be solution treatment, quenching as well as aging liquid. So here it is a graphical representation showing the 3 steps in precipitation hardening. So here the temperature is represented. Here the how much of percentile the copper is included in the thing. So from here the 4% we are mentioning there. So from 4% how it goes on to a certain temperature, it will be like we are treating like alpha here. So here the alpha is formed in the first stage. We can differentiate into 3 stages. While coming to the first stage, it will be reach around the highest temperature sort of 500 to 600 likewise. From there degree Celsius. From there it is suddenly quenched. It will be reaches like the alpha will be super saturated. So the thing will be like this. From there there is some aging process taking place. So the alpha will be changed into theta. So these were the 3 steps in precipitation hardening where the duraluminum undergoes.
Add to the point here, as our friends say, this alpha supersaturated means some amount of alpha is converted into theta. So this theta will increase the strength of the particular material. Okay.
So coming to the solution treatment, so this is the first step of this edge hardening. So heating above the salt's temperature to obtain the solid solution. So hold until the homogeneous solid solutions. The treatment is done all the temperature range around 500 to 548 degrees Celsius, which an alloy is heated to suitable temperature of dissolve. So dissolve the elements. So the soluble phase of copper, magnesium and zinc into soluble solutions. So dissolve the alloying elements uniformly from base to remove the segregation caused during the casting. While casting, we need to remove the elements. So to create the supersaturated solution to dissolve.
So after solution treatment, it comes quenching. So quenching is a process of rapidly cooling down the material. So it has happened after the material is heated up to 500 to 548 degrees Celsius. So rapidly cooling the material, it has happened after the heating the metal after certain temperature, which is 500 to 548 degrees Celsius. During this process, the atoms in the copper atom do not get enough time to recrystal. So it forms as a precipitation. So after in this precipitation, precipitation causes the supersaturated solids like alpha SS in the copper atom.
So while coming to aging is also one of the type where aging is heated below the soluble temperature, like our friend Palak said, 500 to 540 degrees Celsius, and then at this aging temperature, the diffusion I mean the diffusion will be takes place. Also, he is the one where precipitation particles are formed. At this aging temperature, precipitate particles will be formed, and by holding this same temperature for sufficient timing, alpha plus COAl will be formed.
So as a conclusion, we can say alpha is again is again super cooled or quenched. Rapid decooling is done where forms the alpha is become to alpha SS. So some part of alpha is again converted into theta, which is known as CaL2, which is the precipitate. Adding this precipitate will enhance the strengthening of material. So aluminum is not strength as compared, it is weightless, but we cannot compare to steel. But having this type of precipitate in it, we can increase the property of a particular element. Okay, thank you.